What we discussed last class? Get the chart. Who is that? Okay, what we discussed in the last class? How many of you have submitted the assignment? Then why it is showing only 30? Now raise the hands who have genuinely submitted. But it is showing it as like you have only half of the students have submitted. Then system is wrong. Okay, we were discussing this evaluating the algorithms, right? Who is that? Just come front to this first desk and discuss whatever you have. Nothing you can do apart from sitting here and discussing or sitting with your friends and discussing. Apart from that, not even 0.11% you can do. Okay, just listen to the class. At least you will learn something. If you are thinking that we can do whatever we want, we can do a great job in this college, sitting here and murmuring, that is like nuisance. Apart from that, it's zero. Sit, listen, and I don't want anyone to use the phones. And most of the answers were from ChatGPT. So before checking your answers, I'll check ChatGPT also. So by comparing ChatGPT only, I'll come to the conclusion whether your answer is correct. It is from other source or not. Understood? So how much ever technology you know, the same technology I also know. So stop using this ChatGPT. Go to the library. I don't want anyone to murmur there. If you have anything, you just stand up and say, I will listen. Okay. I don't want any kind of voice. Siddhananda, come here. Come to the first bench. Get your bag with the book. Okay. So you might have thought that we can do so much of things without a teacher's notice or somebody's notice, but we will get to know everything. So once we will get to know what we can do, what that we will do. So before you do, we have done a lot of things. Okay. And so if there is any kind of discussions, just let me know. I'll give the proper solution apart from your friends, the best answers from your friends. Okay. Just sit in the class, listen to the class, get your marks if you have that much of strength. Listen, study. That's it. Apart from that, you are here to like not to do all this nuisance things or nonsense things. You are here to study and go. So if you are well and good, if you want your marks or if you want your attendance, attend the class, write the AS properly, submit the assignments properly, you will get your marks. That's it. And I don't want noise in my class. I'll check the running notes once after completing the module. So that running notes should be ready. Okay. So we have discussed about measuring the algorithms, right? We were discussing about evaluation of algorithm performance. So how can we measure? We have discussed about completeness. What is that? Completeness, time complexity, space, optimality. Right. So what is space complexity? Amount of memory required to set the answer. Okay, what is time complexity? How long the algorithm takes time to execute the program. Okay, so what about completeness? In the completeness, we will be checking whether the algorithm guarantees to find the solution or not. So what about the optimality? It is about the strategy which we are applying to find the solution, right? So we have, I have said there are other four factors which we can use to measure the performance, right? So what are those performance measures? Branching factor, depth, search cost, total cost, right? So usually in our theoretical computer science, so we have something like, so to evaluate an state space problem, we will be using a vector, something like vector of P plus vector of E. So what is this vector of P? Set of vertices are the nodes of the path, and what about E? Edges are the links, right? So set of edges are the links of the path. So usually in AI we'll be using, for the search algorithms, we'll be using this actions, initial state, transition models, all this, right? So all this will be calculated by using three kinds of quantities. The first one is your B. B is nothing but the branching factor. So what is branching factor? What is branching factor? So number of child nodes. So that we can say maximum number of successive nodes of any path of any node. So next, what is the next step? Depth. So what is depth? Root node to the any other node. So this we can take number of steps from the path to the root. Okay. So next is your M. So M is nothing but the maximum length of any path in the state space. So this will give you the maximum length of any path till the state space. Okay. So in this we have two major things, that is time and the space. Okay, time and space complexity. So in what terms we can measure the time? Okay, so it is, in case if you are saying it in tree, search tree, so how can we measure? So usually we have that quantity called seconds, hours, minutes, right? So apart from that, so in terms of our search tree, how can we measure this? Traversal time. So this time we can measure in terms of number of nodes generated by while searching, right? So you can say it as traverse also. So this we can measure from number of nodes generated by searching. So what about space? Space. Now maximum number of nodes stored in the memory. Okay. So this we can say as number of nodes stored in the memory. So next we have space. What is space? Search cost. What is search cost? Yesterday we have an assignment, right, in which we have search cost. What is search cost? So this search cost depends on the time complexity. Okay. So and it also require a memory to process the data. So what about the total cost? Sum of all the cost. So we will be combining two kinds of cost. One is the search cost and one more is it path cost? So one more is the path cost. Total cost is nothing but the combination of search cost and the total cost. So yesterday we had an example. So we have written three, right, from Arad. We wanted to find out a solution Arad to H. Right. So in this example, so what will be search cost? Search cost from Arad to H. So we need to write three costs. One is search cost, total cost, and one more is the path cost. Right. So to find the total cost, we need these two. So how can we say what will be the solution or the cost for this? So search cost, we can say it as amount of time taken to search the path. Right. So the search is amount of time taken to search the path. So what is the path cost? Path cost. The length, the total length which we have. So after searching, we got a path. So total length to reach the path. So what about this total cost? Combination of these two, right? So time consider we have taken it in milliseconds. And what about this path? Path will be something like kilometers something, right? So when we calculate, when we add these two, we'll be getting the total cost, right? So solution cost or path cost is the total length of path in kilometers. Search cost is amount of time taken to search the path. And total cost is combination of the search cost and the path cost, right? Okay. So next we have uninformed. Uninformed search algorithms or search strategies. So this uninformed search strategies we can also call it as blind search. Why we call this as blind search? So this is a strategy which will be having no additional information apart from the problem definition. Okay. So that is why we call it as the blind search. So all they can do is they will check whether the state is goal state or not. So apart from that, they will be having no idea about the problem. Okay. So in this, the first one is your BFS. What is BFS? Breadth first search. What is this breadth first search? How it will expand? It will expand in this way or in this way? This way? Huh? Queues. Okay. So which kind of queue it will follow? There are three, right? LIFO, PIFO, and you have said one more priority queue. PIFO or LIFO? What? Huh? PIFO? Say the answer properly. I can hear what? PIFO. Okay, fine. Okay, so this breadth first search, it is a simple strategy in which it will expand the node from the root node. It will start from the root node. Consider we have A here. So it will expand this node, right? So consider we have B. So once after expanding this node or exploring this node, it will not go to the next node of B. It will be checking the next node of A, right? So next after that, after checking this, so if we have one more node in A, so that node will be explored. And after completing all the successes of A node, it will go to the next node of B, right? So once after completing B node, then it will go to the next node, right? So what it is doing, in general, all the nodes will be expanded after given depth. So consider this is the depth 1. So at the depth 1, it will expand all the nodes. So after completing the depth 1, it will be checking the second depth, right? So what we can say, it will start expanding from the root node. So then the successor nodes, after the successor nodes, the next successor nodes will be expanded in the next depth, right? So for this, we have, I have given you the assignment called what is this problem. How many of you have done? The what is that problem is there with you? No? Okay, so consider we have two jets. So for that program, for that problem, we have to write this BFS. Okay. So consider we have two jets. Okay, so this is your problem. So one is 5 liter jet, and one more is 3 liter jet. Okay, so there is a endless water supply. For both the two jets, there is an endless water supply, and there is no measurement marking on both of them. And then what we have to fill at the end, we have to fill 4 liter of water in 5 liter jet. Okay. So what is the problem? We have two jets. One is 5 liter jet and one more is 3 liter jet. Pawas, what are you doing? Is there a phone with you? Keep your phone here, man. From the next class, everyone keep your phone here itself. Whatever it is, man. Just listen to the class. If you are doing something there, it seems like you're using phone only. So we have 5 liter jet, 3 liter jet, right? So and there is no measurement for both of the jet. We just know that is a 5 liter and 3 liter. So there is no measurement marking on that. And then we have endless water supply for both of the jets. And then what we have to do, the goal state should be 4 liter water in the 5 liter jet. Okay. So what we have to do, so what is the solution? Consider we have taken the start space. Start space as 0 and 0. Okay. So in both 5 liter jet and 3 liter jet, there is FD. So this is our start state, start node. So the end node, the goal state will be 4, 0. Okay. So in the 5 liter jet, we should have 4 liter of water, and in 3 liter jet, we should have 0 liter of water. Right. So the first one will represent the X, and next one is Y. So X is the 5 liter jet, and Y is the 3 liter jet. So this notes we have to write. So before going to the problem or writing the tree structure, we should know the rules, right? You have written the rules? Yes? No? Then how you have solved the problem? Okay, so before that, we'll write the notes. Treat it as rule itself. Left side of the rule and right side of the rule. And then description. What is the rule 1? What can be the rule 1? Rule 1, man. If it is difficult for you, we'll take only one rule. Just write the rule name and the description. So first rule will be consider we are filling 5 liter jet. So how can we write this rule notation or like that? So consider we are filling the 5 liter jet. That means the x is 5 and y is what? 0. Or we can write it as y itself. Okay. So the next one. So consider it as 0 only. So consider we are emptying the so empty 5 liter jet. So how can we write this? 0, comma. It can be y or 0, right? So what is the third rule? So consider we are filling the 3 liter jet, right? So how can we write this? 0, comma 3. So next, is it 3, comma 0? So we are emptying the 3 liter jet. X comma 0. Okay, so the x is also 0 now. So next, what will be the fourth rule? Fifth rule. What is the fifth rule? We have seen, so we can fill the water bottle or we can empty the water bottle. So now in case I want to pour whatever water is there in the 5 liter jet, in the 3 liter jet, how can we write that? Can we write that? Say the notation. Huh? Okay, so what is this notation then? X plus y comma 0. So what we are doing, whatever there in the water, in the x z. So we are adding with the y z. So whatever in the x z now, we have x plus y. That is whatever water was there in the 3 liter z, that is also filled with the same 5 liter z. Right. So further we can state that for the empty the 3 liter z into 5 liter z. Okay. So what is the next thing? Since we can write it as now x as 0 and in the 3 liter z we have x plus 1. So what is this then? Empty the 5 liter z into 3 liter z. So we have another 2 rules. So what are the 2 rules? So we have 5 minus y minus of 5 minus of x. This is your 7th rule. So what is the description of this? Pour water from where? So for this the description is pour water from 5 liter jet into 3-liter jug. So in that condition, we are emptying the entire 3-liter jug into 5-liter jug. So here we are just pouring the water of 5-liter jug into 3-liter. So 3-liter into 5-liter. So what is the last one? 8th one? Is here? How can you write it? X minus 3 minus 5, comma. So what we are doing? Pour the water, 5-liter jug, 5-liter into 3-liter. Right. So these are all the rules. So based on the rules, we have to find the solution. We have to write the path. Okay. So how can we write the path? So based on the rules, we are going to write it as here we are saying that we have to empty the 3-liter jug completely and we are pouring it into the X jug. Okay. Here we are just pouring the water, whatever it's there. If we are not completely empty, if we can empty, we can empty, or else we just pouring the water into that jug. Okay. So the solution for we write the rule number and then is there any discussion? Step number. No? We have two jugs. So one is 5-liter jug and 3-liter jug. Okay. So initial state. What is the initial state? It is 5-liter jug and 3-liter jug is 0 and 0. Right. So this is our initial state which we consider at the beginning. So what about the next thing? After we are writing taking the first step. So what is the first step? So we are filling 5-liter jug and this jug is as it is. Right. So this is our step one. What is the next step then? Which rule we can apply? We have filled 5-liter jug. Right. So now this jug is for adding the water and this jug is empty as it is. So which rule we can apply to reach the goal set as 4, 0? Consider the 8th rule. What is 8th rule? Pour the 5-liter into 3-liter jug. So if we pour 5-liter into 3-liter, so 3-liter will be filled. Here the remaining is 2. So this is your step 2. Okay. So after doing this, which step we can follow? 5th. Just check 5th or 4th. Fourth. Okay. So 4th step. What is 4th step? Empty 3-liter jug. Right. So 2 is as it is, and here it is 0. This is our 3rd step. So what is the next step we can take? Again, you are filling the water. You have emptied, right? So consider 6 steps. So what is 6th step? Empty this 5-liter jug, right, into 3-liter. So now this will become 0. This is 2. So this is your step 4. So what is the next step we can consider? So now what we have? We have 2-liter in 3-liter jug. So next step. One is fill the 5-liter jug and this is 2. Okay. This is our 5th step. Okay, last one step is remaining. Is it 8th step? 6th step we can take. One more step. 8. Okay, what is the 8th step? What is 8th step? What we have to do? 4 5 liters into 3 liters. So once we do, we have 2 here, we have 2 here, and we have 5 here. So it will be 4. So 1 liter we are pouring. So this is 3 liter. Already 2 liter is available. So we can pour only 1 liter. That is 3, and here it is 4. So this is our 6th step. So we have this to go step here as 4, right? So this one at the end you can what we can do. We can take the 4th step. So this will remain as it is. Only we are entering this step. Right. This is our solution part. So we have to follow this rule so that we will get the solution. Right. So now what we have to do, the same solution, we have to write it in tree structure. Completed. Done. Okay, how to write this tree structure? First, we have taken state as 0 and 0, right? X and y is 0. So what is the next step? So what we can do, we have to explore both x and y, right? In the bed first. What we can do, so we can pick both the steps. So what is 1 and 3, rule 1 and rule 3. So rule 1 is fill the 5 liter jet. Right. So here we can, what we can do, we can fill 3 liter jet. So after this, we have explored the root flow. So now we have to explore the next successor. So now we have 5, 0 and 0, 3. Yes. So what are the rules we can apply here and what are the rules we can apply there? We have to apply and we have to check. Okay. So once we got 5, 0, so which one we can apply here? Can we apply 3? What is 3? So rules are written in this curly braces, the states are written in this brackets. Okay. Then 3 meters. This will be 5, 3. So what other rules we can apply? Can we apply any other rule? What will we have applied? We have another 8 rule. 8 is there, right? Yeah. So for this we can, so we have now 5, 0 as water in our jars. So what we can do, we can empty this 5 liter jar and we can fill this 3 liter jar and we can transfer this 5 liter into 3 liter. So only these 3 operations can be done. Right. So now we have done rule 3. So what is rule 3? Rule 8 is pour the water from 5 liter jar to 3 liter. So what will be the answer? Here 3, 3. So is there any rule we can apply? Yes? No? Is there any other rule we can apply for this 5, 0? What about this? 0.3. Rule 1. Rule 1. Okay. Rule 1 is what? 5, 3. So here already we got this 5, 3, right? Next. Which rule we can apply here? 7. Is it 7? Okay, if we apply 7, is it like 3 comma 0. So is there any change which is useful for our program? So what about fourth and fifth rule? Can we apply fourth and fifth rule also? So what is fourth rule? Empty the 3-liter tank. So this will go to the initial state. Right. So next, fifth rule is empty 3-liter into 5-liter. So this will become 3 hours. So in all this, which is useful for our program? Problem. So 5 will be useful? No. Right. So this 2 we can explore. So here 3 0 can we explore? No. No. Right. So 2 So which rules we can apply for this 2 4. Next. Only 4. See, when we have 2 has liters of liters of water in it. So we can empty this jug and we can pour the water into this. Right. So we can, or else we can do it in the reverse. Right. Or else we can empty this entire water, or we can empty this water, or we can fill this water. So there are many rules which we can apply for our state. Right. So what are the possible states which we can apply in this technique? So we can apply 4. Can we apply 1 and 2? What about 1 and 2? 1 and 2 is empty the set, right? And we will get 2 comma 2 comma 3. Right. So we will get the initial state which applied second rule, and we will get the state if we apply the first rule. So these two are not used. So what is this fourth rule? 2 comma 0. Okay. So what is the next one? So since it is terminated, so this rule we have to explore. So how can we explore this? 6. So consider I have applied 1, 4, 5. What will happen? What is one rule? We are filling the water. Right. This will become the initial state. So what is this fourth rule? 2 comma 0. We will get the same state. What about fifth rule? Fifth rule. Same we will get, right? So all these rules we done that way. We need this 6 rule. What is 6 rule? 0 comma 0 comma. So this node is terminated now. So we have 0 comma 2. So what is the next step? First step. So consider applying the first rule. Can we apply any other rule? So what is first rule? 5 comma 2. So consider we have applied some 3, 4, etc. What will be states? 3, 4, 5. What is it? If we apply 0, if we apply 3 third rule for 0 comma 2, what will be the answer? 0 comma 3. Right. So next, fourth rule 0 comma 0. What about fifth rule? 3 comma 0. So all this we have terminated here. Okay. So now we left over the first rule. So after this, what we can do? So we are applying the 8 rule. What is 8 rule? 4 comma 3. Okay. So can we apply any other rule? So if you apply 2, 3, 4, what will be the answer? Consider I have applied 2, 3, 4. So we will get the answer. So consider we have 5 2. So if you apply second rule, it will be 0, 2. So if you apply third rule, it will be 0, 3. And for fourth rule, 0, 0. So all this will lead to the initials. So we have got the answers 4, 3. So to make this as 0, so we use 4, 4. So that's the same problem. We have to write it in the tree structure. So we will just apply the rules and we will write the states. So based on the rules, we will say whether that state, whatever the state we have made, whether it is useful for our goal state or not. Okay. So the same rules will be applied for other two programs. Write the rules properly. Next 1, 2, 3, 4, 5, 6, 7, absent. 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43,